Hello, everybody. Hope your day is going well. Appreciate you joining me today to talk about GEOWEB channel testing and performance. Also in this presentation, when we talk about channels, we're really talking about slopes also. So as we go through this, you can refer to it as channel or slopes. A little bit about myself. I've been the chief engineer at Presto for the last 18 years. Prior to joining Presto, I spent 18 years as an engineer consultant, worked on various civil geotech projects, actively involved in REMA committee, which is railroads, ASTM committee, and the ISO committees. So today I want to really try to share insights from both perspectives, drawn on my 18 years as a consultant and 18 years as a manufacturer at Presto. So we're going to start with a good look at the GEOWEB system, what it is, how versatile it can be, and we're going to explore the advantage of it for channel and slope protection, backed by accredited research at Colorado State. We're going to look at the versatility of it. We can adapt to different infill materials, site conditions, flow rates. I'll go through some applications of it for channel and slope protection, and look how to implement it for different flow conditions, and even talk about some energy dissipation. So Presto basically invented the technology with the Army Corps of Engineers back in the late 70s, and we have remained at the forefront of innovation ever since. So we do offer more than just a product. We will partner with you from the initial concept phase right through construction. So our worldwide distribution network is highly experienced not only in Geocells, but also in other geosynthetics. I really firmly believe we have the most knowledgeable distribution network available. So we operate in 4 main product areas. We talk about load support, slope protection and channels, which we're going to talk about today. We also we can do earth retaining walls, whether that's gravity or reinforced walls. We can also do steep and reinforced slopes. We have 2 different types of porous pavements. We have our GeoBlock, which is a vegetated solution, and GeoPave, which is Aggregate. We also make some construction mats called GeoTerra for temporary access, and also some GeoRunner, which is also one type of slope protection, but we're not going to be touching on that in today's presentation. So first, we'll do a little bit of overview if you haven't really been involved or what projects with Geocells, what they really are. So the products come in 3 different sizes. We have our 20V, which is about 8.5 inches, 30, which is 11.5, and 40, which is 18 inches nominal diameter. We have different cell depths from 3 to 12 inches. And we also have different section lengths from 18 cells up to 34 cells. If it is a larger project, we actually can make a specific cell length, basically to reduce any type of waste you may have with the panels. So we do offer a free project evaluation for all of our projects, no matter if it's 500 square feet or 5 million. It's going to include a written summary, calculations, cross sections, specifications, and this evaluation will determine the appropriate cell size and depth for your project. So I really do, and I'll probably say it a couple times, please don't use any standard tables or graphs when you're doing a geocell project, because really every site is different. Especially on slopes and channels, depending on what's underneath it, you're going to, the anchorage is going to be different. So whenever you don't use any standard tables or graphs, we're available. These evaluations are always free. We can turn them around typically in about a day or 2. So the ultrasonic welded seam that connects all the cells together. This really is crucial to functioning of a geocell. The stronger the seam strength, the better performance, period. You got to have a strong seam. We are made from 100% virgin HDP, which provides the strongest seam strength. The cell wall is too stiff, it can overstress the seam and potentially cause failures. And what that's caused by when people start adding things like calcium carbonate to it, or things to lower the cost. So it gets too stiff, the seam can actually rupture in the field. So the second characteristic is the infill material. There are 4 basic types. We can fill it actually with coarse sand for load support applications. When we invented this with the Army Corps of Engineers back in the 70s, we actually called it sand grid until we went commercial with it in the 80s when we changed it to GeoWeb. But so any kind of load support, we can use coarse sand. For slopes and channels, so we can use topsoil and vegetated, usually with some type of surface protection like an erosion control blanket, a TRM or hydro seeding. We can also fill aggregate in it. I'll talk about the research we've done for all 2 of these. And also, if it's a really hard armor system, if you really need some big time correction, maybe against erosive flows or high tractive forces, we can actually fill it with concrete. Here you can see a typical panel, comes tri-folded on a pallet, Each panel is about 8.5 feet nominal width, different cell lengths. Like I said, it comes trifold on a pallet, ships very efficiently. You know, we actually do have a factory here. We're located here in Wisconsin. We build all of our GEOWEB, so it ships very efficiently out of Wisconsin. All our accessories and the GEOWEB are 100% made in the USA under a strict QA/QC program. They do comply with the Build America, Buy America, so the BOB Act. So if you have a project, all of our accessories, all of our everything is made here in the US. We don't offshore any type of materials. We can provide certifications for you if that's required. It's manufactured, like I said, from high quality virgin HDP. You know, it's proven the durability over the past 40 years. You know, we've looked at different ways to maybe make this different, but it comes right back to the same formulation every time we test it. 100% virgin HDP is the best quality, gives you the best seam strengths. You know, it lasts hundreds of years. The carbon black, if it's exposed to, because we had carbon black to it to protect it against UV, but really a lot of times it's buried in the ground. So even 24 hours sun exposure to GEOWEB, it lasts 140 years before the carbon black is degraded. So it's going to be in the ground for a very, very long time. All of our components, they're all actually engineered depending on the type of application you're looking at. This is for slopes and channels. Here we have the after stake clip, and I'll talk about that. We have our after key, tendon clips, but all these accessories here are actually engineered for direct use with Presto GeoWEB. So whenever we do a project, these are all the accessories that you'll see. Like I said, all of these accessories we actually engineered from scratch. None of them are off the shelf. All of them are used with our design evaluations. So the after key, that really is the crucial point. That really makes sure that the panels stay together. It really does speed up installation. Like I said, made from plastic, so they're going to last pretty much a lifetime. It really helps to make sure that the panels remain securely connected and they don't separate. And it really does avoid the corrosion. You know, when we first invented this, we used to use metal staples, but over time, that's going to corrode. So you want to stay away from metal staples. And also zip ties. You know, zip ties aren't made to attach geocell panels together. So you want something that was actually engineered to connect GeoWEB panels and not a zip tie off the shelf. Here's another close-up photo showing the after key. You can see that one of the most recent innovations we had is we added these frictional barbs right here on the inside of the capture key. So it basically just gives you a little bit better interlock between the different panels. When we do our evaluations, we're looking at, like I said, the seam strength is the biggest thing. So we're looking at factor of safety for connection failures, like shearing, splitting, or tearing. So we're giving you make sure that the after key and the factor of safety high enough that you never have to worry about panel separation in the field. These are some anchoring. We call them, these are some Atra speed stakes. They're made out of plastic. Typically 2-to-1 slopes and less, unless there's a liner. We're going to usually anchor it, unless it's a very, very long slope. These are, like I said, 100% plastic. They have frictional barbs on them to enhance the interlock. You can see we have an Atra stake clip molded right onto it. Here's an Atra stake clip. The Atra stake clip fits onto a number 4, so a 1/2-inch rebar. We also have this little gab that goes on, and you could actually drive these in with a Hilti hammer, a pneumatic hammer, versus having to drive in with a hammer. So they go in very fast. So all these accessories for less than a 2-to-1. If you get over a 2-to-1 slope, usually, or over the top of a liner, we're typically going to use tendons and Atra tendon clips. So what the tendons do is they run the length of the panels. We connect these Atra tendon clips. We tie them off on a specified number of cells down the slope, and we'll tell you that in the evaluation how many cells. Typically anywhere from 4 to 8 cells. You can have an Atra tendon clip. You can see how the tendon just twists around the Atra tendon clip. And what this does is it transfers the weight of the soil infill and the GEOWEB panel up to the crest of the slope. We're typically going to have a pipe dead man buried up on the crest of the slope where we can tie the tendons off. If a pipe tendon doesn't work, a lot of times we'll use earth anchors. So we'll work with you and your earth anchor manufacturer to make sure that we have the correct the correct strength. So one of the best things about our system is that we tested it over the last 40 years. Some of the most recent testing we've done is at the, as I mentioned before, the Colorado State Hydraulics Lab. Pretty much anything that's subjected to water is tested at this lab. Dr. Thornton is worldwide renowned as far as hydraulic testing. One of the good things about it, it's located in Fort Collins, Colorado, but it's located about a couple hundred feet below the Horseshoe Reservoir. So it has a couple hundred feet of static head to actually serve the flumes inside of this building. And they also have some outdoor flumes. So we tested all the different types of infill for channels and slopes. We tested topsoil with a TRM. We tested aggregate, and we tested concrete. So the first one I'm going to talk about is vegetated infill. Here you can see the first step is we took their flume box, filled it with topsoil, covered it with a NAG C350 erosion control blanket. What we wanted to do is see what the ability was to withstand high velocities and shear stresses, attractive forces. But the other thing we want to look at is how we compared to riprap. You know, a lot of projects we do around the world, riprap is becoming hard to find, and it's becoming very expensive, not only to purchase but also to transport and place. So we wanted to see how a vegetated GEOWEB system would compare against different sizes of riprap. So we did a total of 10 tests. Each test lasted an hour. We varied some conditions, you know, the bed slope. We varied the bed slope. We varied the slope angle. We did testing in accordance with the erosion control blanket standard for ASTM, which is D6460. That standard is based on two things. We got to have a soil loss after the 10 1-hour tests of less than 1/2 inch. We had to have a blade density of at least 300 blades per square foot. So we had to meet those conditions after 10 1-hour tests. And you can see this is the kind of velocity and the flow of water that was coming down the flume. Oop. They didn't fast enough. Sorry about that. So like I said, we did 10-hour tests. We had velocities over 30 feet per second. We had shear stresses approaching 16 PSF, and we actually had 0 topsoil loss, and we always had more than 300 blades of grass per square foot. So it's a very successful test. Here's really a quick comparison. When we're looking at the allowable shear stresses, which is in the blue, and the velocities here in the red. Here you can see a 12-inch riprap, shear stresses of less than 5 PSF, and velocities less than 15 feet per second. When you look at GEOWEB and the C350, we were more than 3 times the shear at over 15 feet per second, and double the velocity approaching 30 feet per second. So, you know, if you have a temporary installation where you got to put riprap, and you're having a hard time finding it, or actually, I said it's really a big cost issue for a lot of places. It's not fully underwater. A vegetated GEOWEB solution is able to replace riprap. And we actually have models that we can go through and determine the size of riprap that's needed for all of your installations. And here you can see this was the NAG C350 TRM. Basically, we doubled the performance of that erosion control blanket. So a very successful test all around. Just to talk about a couple vegetated slopes and channels. We do a lot of work down in Florida, around Texas, the Gulf states where you get a lot of hurricanes. We do a lot of stormwater channels. This project was a stormwater channel. You know, frequent hurricanes, channel floods, severely eroded channel slopes. So once again, we came in, we got these side slopes excavated, put down the GEOWEB, filled it with topsoil. And how we do these channels most of the time is we have aggregate filled below the water line and up to about 1 or 2 feet above the normal water line to just give it a little bit of freeboard. And then you can see the vegetated slope above it. So as the hurricane water comes in, and the water is going to rise and just vegetated GEOWEB protect the slope. But we also have aggregate down here to protect the slope at all times when the water is flowing. We also do a lot of these another type of stormwater channel. This is actually retaining wall. Here you can see GEOWEB is very easily, it's plastic, so it's easy to cut. You see for pipe penetrations or anything like that. Here you can see this one. Here you can see a GeoGrid. So this was a reinforced slope because the batter was less than about 20-25 degrees. So you can see some GeoGrids holding it back. They filled the front, the back of the walls are always filled with the free draining material and reinforced slopes, but the front, we can fill with anything from topsoil to aggregate to concrete. This, they wanted a vegetated solution, so we did a mixture of aggregate and topsoil. And here you can see the channel. You can see still the aggregate is still in it with about a third, 2/3 aggregate, 1/3 topsoil mix. This was taken a couple months after I think this channel was done. And here you can see this is full establishment of vegetation. So most of our GEOWEB slopes channels, you're not even going to see them. They're going to be covered with vegetation if that's the intent. So the GEOWEB really provides a good way for that vegetation to be stuck inside those cells. We have miles and miles, tens of miles of these hurricane channels all around, whether it's the slope channel or the reinforced slopes like this one here. We have all those, and very successful installation. If you have any type of channels like that, more than happy to help you out. This was a very interesting project. We'd like to show this one. This is out in Vegas. When they get water out there, usually it's in a lot of water at one time. When they get snow melts coming from up, they're going to see a lot of water. So what happened here is a lot of water was flowing down this area. It's on the north side of the strip. Across this wall here is some very, very nice houses. An engineer in the city looked at doing something here. The original intent was to look at maybe doing some gabion baskets or something like that, but the neighbors found out what that was going to look like, and that wasn't something they pretty much frowned upon. That went to the city and the engineer, and they actually came to us, and we turned it into a park. So instead of using gabion baskets for this whole area, which would have been pretty much a useless area, we were able to turn it into a park. You can see they wanted quick vegetation here, so they actually sodded it, but you can see they put a sidewalk down it. Every time the water flows, it comes through this area and flows right out with no issues at all. So we were able to reclaim some land for them to actually work as a little exercise and park area. This is something we come on all the time. People will try to do on steep slopes. This is a airport in Colorado. They're having really big issues with this site. They tried all kinds of different things. They tried hydro seeding without just with hydro seed, but the slope was too steep and the hydro seed wasn't holding. They tried a wire mesh, and the hydro seed, you can actually see the wire mesh if you look close in that. Same thing, it didn't happen. So they really approached our distributor, and we did a free project evaluation for them. Due to the height of the slope angle, here we had tendons and our after tendon clips. When you do these slope projects, we're always installing from the top down. So you're going to pre-assemble the GEOWEB panels on the top of the crest. You're going to get a dead man pipe or earth anchors installed. You're going to tie it off, and then you just basically throw the GEOWEB panels down the slope and just pull them down the slope. So all the tendons or the after tendon clips can be installed on the top. So everything can be done from the crest of the slope. Here you can see the finished solution. You can already see vegetation establishing. This was on the northeast side, so it's not getting a lot of vegetation, but this was taken maybe 4 months after this thing, so it's really vegetated and finally had a solution that wasn't having to slough off when they would get some heavy snows or a lot of snow melt or any kind of melt from the airport. This was a mine closure site we did down in Peru. This is a really tough one. This had 4 25-foot high terraces. Terraces were a little over 60-degree slopes, so very, very vertical. Here they wanted a vegetated solution. It was a mine reclamation project, so there was some specific guidelines they had to adhere to. So we did the free project evaluations. Here you can see looking from the crest of the slope as they're installing it. All these 4 terraces here were designed somewhat this. They were all the same as far as the lifts and the slope angles. So you can see these 2 were already constructed and this one vegetated. This one is just starting to vegetate. And the GEOWEB coming up here. Once again, we have tendons after tendon clips. This was buried to earth anchors at the crest here. You can also see they put down a core fabric and some rock, basically because water would be coming down. It was directed through these channels all the way from the top to the bottom. A lot of water did come down the slopes too, because during the rainy season you're going to get a lot of water, so we had to design for that in our evaluations. So they also put in a biaxial geogrid to have a little bit of extra stability under the panels. And here you can see the final installation taken about a year later. You can see fully vegetated. They went through a rainy season and without any issues, and that GEOWEB is still working great today, about 8 years after it was installed. It's another typical installation. We do a lot of liner protection, whether it's on coal ash plants, landfills, any type of liner. If you need some protection, we can put GEOWEB. We can add topsoil and vegetated. We can add aggregate. Different solutions we've used. We have lots of case studies here. This one, they wanted a vegetated solution, so we put down a non-woven geotextile to protect the liner, the GEOWEB. And we ran tendons, once again, with the pipe deadman at the crest of the slope here. And the pipe deadman was buried into the liner trench. One recommendation I'd make is that if you're looking at putting in a liner, especially if it's got any slope to it, try to use a textured liner. The friction angles between any type of surface protection, say for instance GEOWEB and a smooth liner, is the friction angles might be in the low teens. But if you use the texture liner, they're in the low 20s. So it's significant when you're looking at trying to anchor in the anchor trench. Usually we can always anchor in the same anchor trench as the liner. But once again, we'll do a full project evaluation for you to let you know what the anchorage requirements are. And this is the installation after vegetation was established. Protect the liner. This is one area that's really beneficial. I'm sure you see this on road shoulders all over where you're driving around. A lot of scour, undercutting. That picture is pretty typical of what you see. The scouring, the shoulders get a lot of runoff. You get a lot of erosion. You get some sub-base failures, and so we do a lot of these type of projects. Seems like we're always doing one of these at every single day. We're working on one of these projects around the world. So you can see it from this. This is a 2-to-1 slope, so you can see we use the Atra stake clip and the number 4 rebars on this one. Driven in on this one, about a 3x3 cell pattern. So you can see the problem, the solution with the web, and then what it looks like after it was vegetated. So another successful project. We do a lot of roadway embankments. This is actually on a railroad. This is out in Montana. This is roadway and a rail, but this is for the rail. You can see they wanted a vegetated solution. Once again, we put down, this was also a 2-to-1 slope. So you can see down here, we did use tendons on this one because they didn't want to have to go on the slope. So we actually used tendons for the installation. But you can see what it was here, and then after vegetation was established. We can also do very steep slopes. These 2 pictures here from a project we did out in California a couple of years ago. You can see that how much scouring was happening on this. This is about a 75 to 80 degree slope, so almost vertical. So what they did here is you put the place of GEOWEB after they established some type of after they got all the vegetation off of the slope, and you can see these pails down here. They're mixing a clay and a topsoil mix and almost hand placing the topsoil into the GEOWEB. And then what they did is they wrapped it with a very strong core fabric, which you can see here. And then they added some plantings, and they came back and actually hydroseeded it too. So we can do very steep slopes. So if you have something that you can't figure out that has very severe limitations as far as trying to do something with a house above it, we can actually provide an evaluation for a vegetated solution. So the next one is aggregate fill. Aggregate fill is a little bit different. We did different cell sizes. We varied the slopes from 2% to about 50%. We also changed the rock sizes. We ran, different, once again, 10 different 1-hour tests. You can see here what it looks like as the So what we found out from this one is that we actually maxed out the flume inside at Colorado State. So they haven't. We went to the outdoor flume. And we did 5 total tests. We kept the slope pretty consistent at about 17 degrees. Flows to 125 CFS. We did the rock size at 1 to 2.5 inches. If you look closely on this slide, I'll run this. This is the test, one of the 5 tests. You can actually see the aggregate being confined inside the GEOWEB. Oops. So the intent of doing the aggregate testing was twofold. We wanted to look at, once again, replacing riprap. So we wanted to see if you couldn't use a vegetated channel, as I showed in the previous section for our testing at CSU, maybe it's under constant flow or a lot of flow. We wanted to see how we compared to riprap. So, like I said, the output was Dr. Thornton and his PhD students did a linear regression analysis for us. And based on these velocities here of 18 feet per second, shears to 16, we can actually reduce the rock size or riprap size up to a factor of 10 times. So, based on your site, we can run this model, and I've run this model thousands of times since we've had it. Basically what we're doing is all I need is the slope and the flow rate and the bed width. So if you give me those numbers, I enter the slope, I enter the flow rate divided by the bed width to get unit discharge. I'm basically changing the size of infill material. And what that does, it shows you a comparison between, maybe 2 different formulas for size of riprap, the Apson-Johnson one and the Army Corps of Engineers. It also will tell me what size of GEOWEB. Remember we talked about the 20V, 8.5 inches diameter to 30V, which is 10.5 to 11, and the 18-inch for the 40 feet. It'll tell me which one is going to be the best fill material for it. And from that evaluation, we can go ahead and provide a free evaluation for you that gives you the size of the GEOWEB, the depth, and actually the infill size. So it's a project we did out in Arizona. This is for the Gila River Indian Reservation, south of Phoenix. Once again, just like that Las Vegas case study, when they get storms, they're very intense. They're leading to erosion and flooding in adjacent subdivisions. So, and they also use this area as a roadway to get up into the mountains. So they had to do something to repair, and it was really critical because the flooding in the rainy season was going to come out in Phoenix, so they had to make sure. So this one is about a mile-long channel, and it came from the bottom of these hills. It ran through, and a bunch of other channels actually came into this one. So we did the full evaluation here. We recommended actually 2 different sizes of GEOWEB, a 6-inch on the uphill side, and a 4-inch on the downhill when some of the other panels were coming. You can see here the pre-folded panels. We did put a non-woven geotextile underneath it just because it was pretty sandy, so we didn't want to have any scour below it. Basically just cleared the existing vegetation, got to that sandy subgrade. They graded it and compacted it. What we did here is it was up to about 100 feet in certain areas, so it's a pretty wide channel. We wanted to have like 3-to-1 side slopes. That was the final grade. You can see these yellow hoses. That's for the Hilti hammer, hydraulic hammer, because they're driving in after anchors just to keep the GEOWEB from moving. You can see the stakes. They're getting ready to be driven into the ground. But on this one, we did about 42 different options, looking at 42 different stations and flow rates, bed sizes, rock sizes to determine the best infill material. So a couple of basic channel calcs. After running the calcs, we had all these different types of different channels. We came up with some different rock sizes, but we actually settled in on a local with a 2.5-inch crush material. That was something that was locally readily available and at a pretty low cost. We used that to fill the GEOWEB panels, and you can see here just cross sections that we did from all these different stations. On one of the sheets, you can see different heights, the bottom widths. So every one of these stations we provided evaluations for, just to make sure that we had the right rock size and the right cell depth. So here you can see, once again, very easy to cut around penetrations. So it's very easy to, a lot of times we're going to wrap, you're going to take that geotextile non-woven, you're just going to wrap it out in front here so nothing gets back behind it. And like I said, the infill was waste rock from nearby quarry. You know, it wasn't the greatest, but it was locally readily available, and it went down very quickly, saved them a lot of money. And once again, I mentioned before that they would use this route previously before it got severely eroded as a way to get up into the mountains with the UTVs on the vehicles. So that's one of the really big advantages of using GEOWEB-confined for aggregate. Once this is down, you can use it as access way. So all the construction trucks, we looked at, you know, the CBR, the subgrade, and made sure that this wasn't going to damage any of the cells. And so we're doing a load support evaluation in these cases, along with the slope and channel evaluation. So it actually served two purposes. This was a really interesting. This is a project we did from Calgary. It's called if you're looking west at the Rocky Mountains, this was like eastern and a southeastern facing wall. Originally, they designed it as a vegetated wrap wall to get some erosion growth, but it never worked. So they had some issues with that. So they went back to the architect. We've done work with them. This was about 160 meters long, but a 1-to-1 slope angle, and the heights range from about 15 feet down to about 5 feet. So it was really hard because if you look here, you know, that the highway was right next to. This is the highway going out to the Rockies. So as you can see the slopes, we put down a non-woven geotextile. Here's what the architect wanted to look like. This was his rendering, and he wanted to basically look, if you're looking at the wall or the slope, you can actually, it sort of mimics what the Rockies look like. So that's what he put in. We actually use different types of rock and different colors of rock for that installation. You see it a light brownish and a dark brownish gray. This one we used a combination of tendons and earth anchors. You can see the tendons once again through the geopanels, non-woven geotextile, anthrotetic clips tying off. This one we actually used earth anchors driven at the crest of the slope because we didn't have any where to dig or to do a pipe dead man. So we actually used earth anchors tied to these tendons. And here you can see what it looked like after everything was constructed. So it actually it looks really cool, especially at nighttime. You can see the when you're looking at the Rockies, you can actually see this. Really pretty cool. So we actually do something like that. If you have a project where you want to make it more decorative, we can work with you and your architects to come up with a GEOWEB slope system or a channel. Once again, we do a lot, just like the vegetated. This is a project over in the Philippines. Never could get vegetation to grow on here, so they ended up. So we do a lot of road shoulders, not only vegetation, we also do them with aggregate, especially in areas if you don't want any kind of animals getting up here. Most of our railroad shoulders are going to be rock because railroads don't want to see deer and things getting up into their tracks. A lot of it's going to be aggregate. Once again, bridge abutments. We do a lot of bridge abutments. You do it, you know, we've done concrete bridge abutments too underneath, but we do full gravel ones. So if you don't want to save some money, it's a federal project. We get federal wage rates. We can actually look at, and I'll show you the concrete next. But you know, this will save you a significant amount of time rather than having to form concrete under these bridge abutments. Last one I want to touch on is concrete infill GEOWEB for slopes and channels. So this one is pretty straightforward. What we want to do here is we want to have a very robust system that we could use to compare it against concrete. And I mean concrete, I mean poured, cast in place concrete, rebar, all the formwork. So we use the GEOWEB as the formwork. We did 3 tests on the outdoor flume. We maxed the slope at 2-to-1. We had all the pumps running, and we maxed the flow out. We're the only geosynthetic today to max the flume out. We hit velocities approach over 36 feet per second. That's all it could get to. Shear stress is over 21 psf, and like I said, we maxed that flume out. This was only a 3-inch deep GEOWEB. So if you have a really challenging application, whether it's a channel or slope, you know, maybe subject to some very high flow rates, a lot of scour, a lot of tractive forces, you know, we can look at doing a GEOWEB system. Here you can see it's going to save you a lot of money because, like I said, GEOWEB is the formwork. It is the reinforcement. You're pouring it, you're screeding it right off to the top of the GEOWEB. You're actually going to see a little bit of the GEOWEB because anything above it is not confined. So you can see right here, a little circle, little diamond shape. So that you're going to screed right to the top. You can see the installed, you can see typical concrete installation. You screed it, take a board and screed it right to the top surface. Here you can see they're doing normal installation. These are about 60-degree slopes here on this culvert outfall. So what they did here is they basically placed this by hand, and then hands trawled it into the GEOWEB to make sure that it was all nice and vibrated into the cells. What you do is, what we tell people is that, it's going to be typical standard concrete, nothing special, typical air contents, typical water contents. Slump, you're basically just going to adjust it in the field. And it's pretty fast installation. This is a project, we do a lot of these for the Bureau of Rec out in Colorado. They're drainage channels coming down from the mountains. They want to get the water out west. So it's, here you can see, this is one of the standards that they did. They have a liner underneath to make sure they're not losing any water. They're using 2-to-1 side slopes. Here you can see a really good picture of those tendons here tied to the pipe dead man. So part of that evaluation will give you the size of the dead man, the depth that is buried, how many tendons per panel, the after tendon clips. So you can go ahead and install it. Here you can see they're just using sandbags to hold the pipe in place as they pull the GEOWEB down the side of the slopes, and same thing at the bottom of the slopes. So what they do is they'll come back and fill that press section up. And you can see here, as they're filling the concrete, they're basically pushing the dirt back in to make sure, once again, just screeding it right to the top. This one, they don't need the GEOWEB on the side slopes or on the bottom. I'm sorry, the bottom slope. They just ran it to the sides. So you can see a full concrete, panel on the sides and just the liner on the bottom. And these are pretty much 100% underwater. So there's always water flowing except in the wintertime. But here you can see it after installation. As I mentioned before, you can sort of see how they troweled that right to the top of the GEOWEB channels, or the top of the cell. And you can see the finished installation with water flowing down it. This was another interesting project. This was for a railroad down in Texas. This was a couple of million square feet project that they were originally going to use concrete, poured concrete in these channels here. So they're going to use 6-inch reinforced concrete, so formwork and rebar, and then 4-inch grout bags on this slope. So they came to us after the bid. The contractor, we do a lot of work with them. They asked if we had any, what about GEOWEB, using GEOWEB for these, this slope and this channel. We actually did an evaluation. It was accepted. Here you can see if slopes were basically excavated out, 2-to-1 slopes, varying height, but around 20 feet. When they did the evaluation, we saved them millions of dollars because they got rid of all of this reinforcement. This is a huge area. It goes all around this intermodal yard. So we went with 4-inch GEOWEB in the channels, and we went 3-inch GEOWEB on the slopes. So it not only saved them money but just the amount of concrete that they poured, because they're only pouring, 3-inch here and then 4-inch GEOWEB in these channels. So you can see here in the next slide, significant how big this area was that they're doing. Once again, it's very easy to pour around these. Just butt that on the GEOWEB panels right up to any culvert pipes and pour it. You can see once again, non-woven geotextile underneath it. It's not required. It's not a bad idea. How we size these two we want to make sure that groundwater isn't an issue. So we'll put some type of weep hole in this. We've also used mud valves, believe it or not, like these on, say, water tanks, clarifiers, to let any kind of water come from below and flow up into the channel. So we've got multiple ways we can reduce pore pressure if pore pressure is an issue under the GEOWEB. Here's another interesting project. This was down in North Mexico, about a little over 500,000 square feet of GEOWEB. This was, once again, was for a mine also, but this one had velocities up to about 25 feet per second. So they couldn't go with an aggregate channel due to the slopes. but they had to have something hard armored. They couldn't have vegetation. So what we did for that one is we looked at it into a concrete filled GEOWEB solution. These are a little bit steeper, so that go up 2 to 1, 2.5, 1.5 to 1 in certain areas. You can see they did put a liner on the bottom of these channels, just to protect the base. You can see they're pouring them in sections, so you can see how the GEOWEB run the tendons here because of that liner. They ran the tendons all the way through, so a dead man on each side of this channel. There you can see them just pouring. And it's the good thing is you can actually stop. I mean, you can stop pouring and start repouring with this system. And it doesn't matter because it'll actually fold through the cells. So what you're going to do is just leave some of it, leave some of those cells open, and you start up the next day. All you're doing is starting up again and having another pour. Same thing with construction joints. You don't need them because GEOWEB provides every single cell really acts like a construction joint. So you don't need any type of construction joints for a GEOWEB. This was also interesting because when we came to the end of this channel, we wanted to make sure that we didn't just change the scour from the channel to the end of the channel. We were getting down to the bottom, so we designed this really nice energy dissipation system. But it got to the point where they're behind time, and we talked to the contractor and engineer, and then we just used some big boulders to stop the flow, basically just to dissipate that energy. So we wanted to make sure that when the velocity got out of here, it was very low because it's right at the bottom, so it can just flow out and flow down into the thing. So it's pretty easy to do. But here's what an energy dissipation system typically looks like. We use the Army Corps design for this one, so we're actually sizing not only the size and the depth of them, but the spacing of them. So you can see here they're actually pouring these independently. You can also, a lot of people will pre-form these away and just dowel them in. So there's different ways of doing it, but here's what it looks like after it's poured. So each one of these is energy dissipation. You can see this is also from a mine site down in South America where the water was coming in, all these where the water came down. And this is what it looks like afterwards. So this is what it looks like if water is flowing down energy dissipation. So the intent is to have it when it gets to the bottom to have zero energy. So very, very slow flowing water. So with that, just want to talk about some of the advantages. It really is flexible in the design. We got, with different cell depths, different lengths, different sizes. We can, depending on what type of channel you have or slope, we can use topsoil with some type of surface protection, like erosion control blankets, turf reinforcement mats, or hydro seed. We can use aggregate. We're going to use the size that's right for your site. So if you have a scupper coming from a bridge abutment that's only going to be 200 square feet, we'll still run the model for you to tell you the depth. If you can use an aggregate to reduce riprap size, we can also run it for that, or we can fill it with concrete for the real challenging problems. So it is a complete system. That free evaluation, like I said, please don't use any standard tables or graphs. We're going to give you that written summary. We're going to give you the calculations. We're going to give you drawings. We're going to give you type, maybe if you have a geotextile, the type of anchorage you need. Everything that's involved in the project will help you out with. And as I mentioned before, we'll work with our distribution network and make sure that all the necessary products are included in the evaluation. If you're interested, I do have certified summaries, independent research summaries from Colorado State that Dr. Thornton put together after his research. I have it for, vegetated, aggregate, or concrete. So if you have something that you want to know, just let me know and I can get you a copy. They're also on our website at prestogeo.com under the channel application. Here's that. Oops. If you go to, here's our website, prestogeo.com. If you go to the design tab here, and you click on channels, it's going to pop, it'll show you those research summaries. But, we have a great website. If you want to sign up, the website or the webinar today won't be on here, but there's hundreds of videos, webinars you can take. You sign up, it'll actually keep track of all of your PDH credits. So if you need that, that'll be in here. You can, like I said, you can take as many webinars as you want, and it'll actually keep track of you. You have a product tabs, application, design, installation tabs. So if you're interested in that, please let us know. If you want to get a free project evaluation, you just click right here, and then I'll bring you to this site, just fill it in. You can actually attach geotech reports, maybe some drawings or anything that you want to, anything you can attach, is helpful. Within a couple of days, we'll get back you to a full evaluation. Like I said, this is just a typical slope cross section here showing, the vertical height, slope angle, GEOWEB 40V or 30V4, which is a 4-inch web. It's going to show you all the dimensions of the dead man system here with a 6-inch pipe buried 4 feet below grade. We're going to give you the tendons, how many tendons per panel. We're going to give you the after tendon clip spacing. This one's every 6, so every 6 cell down, or about every 6 to 7 feet, you're going to have an after tendon clip. Same thing with channels. We're going to give you same type of cross section and plan view showing the tendons, showing the stakes. So you'll have a full knowledge when you go to specify it on what you're actually looking at. So like I said, we've been doing this for 40 years, and we guarantee every ship meets or exceeds our specs. We will provide evaluations for every single project. So, please take advantage of that. Reach out to us, and we can do that. Like I said, usually a day or two. And then for today's PDH credit, with our webinar dashboard, I say you can easily view all those library of all the webinars, download your own PDH certs. But these online webinars, ones are a little bit different. So the certificates will come from live webinars are basically managed on the on-demand or to go to a webinar. So with the next couple hours, you should get a download link to obtain your PDH cert. In 2 to 3 days, if you don't get it, check your spam folder first. But most of the time, you should get it. But every single webinar, there's a handful of people that don't get their PDH certs if you're interested. So just reach out to us at info@prestojeo.com, or you can reach out to me here's my email right here. So with that, I really want to thank you today. I know everybody's time is very, very valuable, especially in the summer months when you're out doing construction projects in the field. So I really thank you for that. And I wanted to leave a good 10 minutes for questions. Let me see. You have any applications, case studies for leaving live stakes or actually potted? Yes, we have. Yes, we have lots of actually potted plant material. So where's the project manufactured? It's manufactured in the U.S. here in Wisconsin. Expansion joints. No, we don't need them because each cell acts like the expansion joint. Slump. Most of the time we tell them like a 4 to 6% error, a couple thousand psi minimum concrete. 2 to 3 inch slump. Not, and like I said, most of the time it's all based on, if it's 3-to-1 slope, it can be a little thicker than or a little thinner than a steep slope. So it all really depends on. I always tell them to undo the slump first, and as you get out in the field, go ahead and adjust it in the field to make it flow into the cells. And use the GEO for grade control structure energy dissipation. Yes, we use it all the time for grade structures. I'm working on a couple projects right now over a coal ash where we're using it for that exact same purpose. The presentation will be on our website tomorrow. So if you're looking for a presentation, you can go on our website. What is vegetation for engagement with underlying lining which limit root depth? So that's a good question. So we have the different depths of GEOWEB. So anywhere from 3 to 12 inches. So what we're doing is we rely on, we're not plant people by any means, so we're going to rely on the local people for that. Like if you have something that needs 6 inches of depth, then we're probably going to go with the 6-inch GEOWEB. So resistance to wildfire and controlled burns. Yeah, we have instances, especially in Colorado, where of course the concrete was not an issue, but we've had some, it is plastic, so it can melt a little bit. Burying in the ground, it typically doesn't burn, but it does scar the top of it. That's a great question. Let's get another comment on the PowerPoint presentation. That'll be online later. Another one on the specking the vegetation. No, but we'll work with you on that to see what type. Most of the time on these slopes and channels when it's vegetated, it's just hydroseed. We're spraying on the hydroseed guys are going to know what works the best and what tackifiers to use, what type of seed mix to use. So they're the ones we typically rely on because they're the experts in that area. So depending on the slope angle, they're going to use different tackifiers to make sure it sticks on at different seed blends. So that's pretty much what I 90% of the time rely on. Sometimes we do work with like landscape architects who want to put trees in it, which that's not a problem at all. We can easily cut it and put the balls in the middle of the GEOWEB panels, not a problem at all. Subgrade prep options, just so it's not a complete wave. Usually you want to have a somewhat flat surface because you could get some things underneath it. But we can easily, look at a little bit of contours also. Most of those times we're going to put a non-woven geotextile. So the weight of the GEOWEB, the liner or the non-woven, and the weight of the infill is going to push it down into that maybe a little hole or pocket. So you're going to see the little undulation on the surface and not underneath the panels. So that's pretty much what that is. Yeah, a couple people have asked about the evaluation of time. Yeah, usually 1 to 2 days, depending on how many evaluations I'm working on at that time. I would say 2 days max. If we don't get it back to you in 2 days, we probably would have already called you to ask questions because maybe we don't have enough information. So we're actually going to reach out to you and maybe ask some questions or clear up some questions that we have, or have a Teams meeting. Do a lot of Teams meetings, 10-15-minute Teams meetings every day, just talking to engineers and architects about their projects. So maybe we might start talking about concrete fill, end up using aggregate or even vegetation, or vice versa. So please reach out, email or phone if you have questions on that, and we can help you out. So I think a lot of the questions are pretty much the same, so I think I've covered them all. But like I said, if you have any more questions, here's my phone number. And here is my email address. Reach out to me anytime and we can help you out. So with that, I would like to thank you again, and I hope you all have a great rest of your week and great upcoming weekend. Thanks.